total mass divided by the total length because we're assuming uniform mass density. So to actually calculate the integral, I change the dm to m over L dx, like so. And I do the integral, 1/3 x cubed, because it's x squared. And there you go, 1/3 ml squared. That is the moment of inertia for a ruler or something spinning around its end. Okay? So keep that in mind. That's essentially, quote unquote, its mass, sort of rotational mass, is 1/3 ml squared. What if you have the same mass, the same length, but you're rotating around the center point? So this time I'm rotating around the center point, right? So technically I would have to integrate from minus L over 2 to L over 2, m over L x squared dx. This is the integral of, by the way, x squared. Why is x squared here? What is x squared? X squared is the r squared, right? It's the rotational distance from the center, from the axis to the dm. And so I get 1/3. Yeah, I get 1. So, but you notice I get L over 2. It's not just a half, you see, because you end up with L over 2 cubed, which gives you a difference of anyway, it's, long story short, 1/12. 1/12 ml L squared, which is what? That's 1/4. That's one quarter of 1/3 ml squared, right? In other words, if you spin like this at the same angular rate, a ruler around the center point, you have only 1/4 of the energy if you spin it at the same rate, angular rate, around its end point. There's much more energy if you spin it around the end. Of course you know this if you have brothers, because you would never hold a stick in the middle and then hit them, right? You hold the bat by the end before you hit them in the head, or whatever. It's a Nerf bat. It's a Nerf bat. And I know you guys aren't Trump supporters, so you're not ready for other things yet, so. My favorite bit of Trump trivia from the weekend was the comment by Bill Maher that Trump is really the white Kanye West. It's an amazing concept. Both tweet. There's just so much to it. I don't know. I usually get asked the question shortly after that. You think Kanye West is going to run for president? It makes me wonder. Didn't he already? I mean, I don't know. For the next one? Okay. I was thinking. It seems like he would. There's another way you could do the last example besides just direct integration. Some of you guys are like, well, it's just half of the other one. Your intuition is wrong, but not baseless. You can divide and conquer. You can say, well, if I have a ruler around its middle point, right, and its length L, then it's really just like putting two of the problems we already solved together with L over 2 with ML over 2 and L over 2 and M over 2, right? Like it's half the mass, half the mass, half the length. And is inertia additive? Yes, inertia is defined in terms of an integral. So the moment of inertia for the blob will be like the moment of inertia for this piece plus the moment of inertia for this piece. That is true. Moment of inertia is additive because it's defined in terms of an integral. Like that. So you can divide and conquer. And if I was to do that, well, the moment of inertia for half of it would be 1/3 mass of the first part times length of the first part cubed squared, which is this, which is what? 1/3 m over 2. What's that? That's a quarter. 4 times 2 is 8. This is 1/24th, right? But you got two of them, so it's 1/12. You could also think that way. That is true. No integration, right? Just building it up from another thing you know. What's the moment of inertia for a cylindrical mass of mass m at radius r? So what we're talking about is like a coffee can, but you've removed the end of it or something. You're just rolling it along. Or maybe like a 55-gallon drum where you've removed the cap, so it's just an empty drum and you're just rolling it, right? Just an empty cylinder, just the shell. Well, it's kind of like all of the mass is, you know, the radial distance from the axis of rotation, right? So the integral is not really necessary. It's this this r is constant over the whole stupid thing. So you pull it out of the integral and you just get mr squared, which is intuitively obvious, right? Anytime you have some kind of system of mass where all of the particles are the same distance from the rotation distance, you just take total mass times radius squared. That's your moment of inertia. But if it's not that, then you have to integrate. Like here, a solid cylinder, right? A solid cylinder, well, then what you can do is you can chop it up into cylindrical shells, right? You can chop it up into cylindrical shells. The moment of inertia for the shell radius x is just x squared dm. Well, what's dm? Well, dm is the mass density times dv. What's the dv? Well, it's the circumference times the dx, right? So a little thickness is the dx, 2 pi x is the circumference, L is the length, so you're taking the actual area of the cylinder, multiplying by the thickness, which is dx. That gives me the volume of the cylindrical shell. You're like, cylindrical shells again. Man, I know, they matter, right? So here it is. Pi's cancel, and you end up with this lovely creature. Then you have to integrate that from 0 to r, and you get 1/2 mr squared. Now, I might ask you to derive one of these. I try to pick one which doesn't require full-bore knowledge of calculus 3. So it's much more likely I ask you to derive like the ruler one than this one, right? I mean, this one's still within reason because I do think this is very much goes hand in hand with calculating volumes by cylinders, which you do in calculus 1. Sorry, I have a 7-year-old. But there you go. I mean, so it's just 1/2 though. Yeah, it's very simple. If you had something like something in between, like you had a thick cylindrical shell, like that went from inner radius A to outer radius B, you end up with 1/2 m a squared plus b squared, interestingly enough. How about the moment of inertia of a sphere? I'm glad you asked. Well, a sphere can be chopped into cylinders just the same. So what I do is I take the cylinder, take the sphere, and chop it up into cylinders, right? And so what's the volume of a typical cylinder? It will be 2 pi r, that's the circumference, 2h, that's the height, right? And dr is the thickness. Multiply that by the density, mass density, that gives me the dm. Now h here I can get in terms of big R squared minus little r squared by that triangle. And then I just need to integrate that thing from 0 to r.
Is this a hollow sphere or a solid ball?
Solid ball. Solid sphere. Hollow sphere, mr squared. Oh, no, not mr squared, excuse me. More interesting, because a hollow sphere has the points along the axis aren't rotating at all. I mean, the points on the equator relative to the axis are rotating the fastest. They have the most kinetic energy, whereas integration's required for that, yeah. But for a solid sphere, which is I'm doing here, it's 2/5 mr squared. It's a volume integral, really. I'm glad you asked about that, though, because that's what? Oh, come on. Where's my? Ah, no way. I got no spherical shell. Oh man. Un momento. We can't have this. This will not do. Where did I put my calculus 3 notes? Did I hide them in here? Come on. Let me look at this. Aha, aha. Fine. You can leave. I guess I have to calculate it next time. That requires a surface integral. Yep. What's that?
You don't have left?